Hello everyone. This lesson we're going to talking about unbalanced delta load to calculate the line current. Last lesson we talking to calculate the neutral current in unbalanced Y load. So we're going to move on to the delta load in this lesson. I have a 3 line for supply 240 volt 3 phase. I have a 3 load connected in delta. But this time, those loads are unbalanced. I have one load is 40 ohm, another load is 60 ohm, last load is 80 ohm. They connect in the way as delta. The value I write down here, I1 is going to be the phase current goes through 40 ohm. I2 going to be the phase current goes through 60 ohm. I3 will be the phase current goes through 80 ohm. Now I have 3 line current here, line current A, line current B, and the line current C. So this time we're going to calculate those 3 line current. First, before I calculate line current, I have to calculate phase current. Phase A, voltage divided by resistance, give me 6 amp. I define that at 0 degree. Phase B, 240 divided by 60 ohm, give me 4 amp. I define that by 240 degree. Phase C, 240 volt divided by 80 ohm, give me 3 amp, the 120 degree. So these 3 current is the phase current. They are 120 degree apart. Now I can calculate the line current. The first method I'm going to show you is using subtraction the 2 vectors to find my line current. If I look at point A here, this phase current 3 going to go in the point A. Phase current I1 going to came out that point A, and the line current line A going to go into that junction point. So the line current A will be the difference between the phase current 3 and the phase current 1. By looking at which one go into the junction, which one go out of the junction, line current A going to be phase current 1, subtract phase current 3. But they are all vectors because they have a degree related to it. By using the vector calculation, I got line A got 7.94 amps at negative 19 degree. I can do the same thing for line B and the line C. Just looking at each junction, which current go into the junction and which current came out of the junction. By use vector subtraction, I can find all my 3 line current by subtract 2 phase currents. One thing I want to remind you to remember, when you do this calculation, your line current have to be higher than the 2 phase current value. If you did a calculation, your line current value is smaller than any of the phase current value, tell yourself you did the calculation wrong. If you do proper calculation, your line current always will be higher than the phase current value. So this way we're using subtract 2 vector to get our line current. Another way, same thing as we did in Y for neutral current, we can use a math formula to calculate the line current. So this is the formula. The line current equal to the 2 phase current going to the same junction squared plus the 2 phase current times together. Take the square root, we give us the answer. By using the math formula, you're not going to have the degree. But as an electrician, we don't need to worry about degree too much. We need to worry about the value of the current. So by applying to line 1, I have a 2 phase current, 6 and 3, square them plus 6 and 3 times them together. Take the square root, I'll get a 7.94 amps. This calculation is the same as using 2 vector, subtract them. We have the same current value. Just by using the math formula, we're not going to have any degree related to it. But in here, we don't worry about degree too much. So I did the same thing for line B and the line C. This is two different ways we can calculate the line current in an unbalanced delta system. If you have any question, you can send us email or contact us online.